Okay, welcome to another Tactical Technician video from Diag Nation. This is a quick scope diagnostic video. Basically in front of you see that is one scope lead, that's all we're going to see, and that is on the purple wire going into the fuel tank on a GMC Sierra, I believe. Basically it had a code, it coded for P0451 for fuel level sensor high code, and first thing I did, I hooked a scanner to it, obviously, and I got the code. I looked at the PID on the scan tool graphing, and it was a little jumpy, which can be validated by the scope capture. Basically, that's the fuel level sensor going into the sensor. Is basically a variable resistor. As the float changes, the resistance changes, and the PCM sees a varying voltage to determine how much fuel's in the tank. Here is the schematic. It's a simple one. See if you can take a little screenshot of this. Basically, we have a fuel level sensor in the tank. That red thing is the float. The scope is just one channel, channel A. I have a long test lead right up to the gas, as far as I can go. I use a piercing probe right on the purple wire, right on the top of the gas tank as far as I could reach. Basically, the PCM sends out a 5-volt reference to that variable resistor in the gas tank, and that changes resistance as the level of fuel changes. That's on the purple wire right here, as you can see. So I'm at the tank. Basically, look at your scope capture. Just take a screenshot of that right there. Okay, and as far as the scope, we're at the fuel tank, looking at the fuel. I'm not really rocking the vehicle at all. Just the vehicle is just sitting there on the rack on a drive-on ramp. Alignment ramp, and you can see the deviation. See the wild swings as the voltage changes. And what I didn't capture, basically, I disconnected the connector at the fuel level sender at the tank and kept the scope lead up. And the blue line, I don't have a capture of it. Basically, the blue line went to a solid 5. You didn't see any of these dropouts here. It was a solid 5 volts. We know that the PCM got the voltage there, and basically, we determined that it had a bad fuel level sender, and we recommended a fuel level sender, and we put one in. And the post capture, as I said, was probably not 5 volts, but maybe it was like I don't know, maybe 3.2 volts, but it was level. It was level. It didn't have these wild shoot downs of voltage where it was we deemed from a faulty fuel level sensor. And I did also check the ground. The ground goes back to the PCM, and that was good. And I verified it also with a scan tool. I looked at the graph on the scan tool after we put the new one in, and it was nice and steady. Anyway, this is Diag Nation signing off, and thanks a lot.